Hi, thank you for joining us today. Very excited to have you here. My name is Craig, and I look after our analytics, big data, and AI businesses for AWS in Asia Pacific. Today's session, we're going to focus on how to build a modern data platform on AWS, and specifically how to do it so it's really driving better business outcomes. Now, it's not that our customers haven't wanted to do this. For a long time, they've wanted to, but there were some things that held them back from being really effective at building a good data platform. And the old approaches that they had kind of held them back. So one of the things they struggle with was the people that they had tend to be very specialized. And these highly specialized individuals were caught doing a lot of heavy lifting, having to set up their own infrastructure and having to patch software and doing things that weren't really valuable for them in the business, just things they had to do. The second is that the processes that they had before, they were planning 9 months and 12 and 15 months out before they'd even start to get their first results. It was because their procurement cycles were slow. They had to issue RFPs and do comparisons between different products, had to buy servers and install them in data centers, and the process was just really slow, and in some ways it could be considered broken. And the third and the final is around the technology. And technology really comes down to what was designed 10 years ago or 20 years ago. It was good at that time. But the business cases today are quite different. They have different types of data. There's different time requirements. There's different responsiveness requirements. Processing real-time and streaming data and non-traditional data, they just don't work well on old platforms. So there's a real rethink that customers are having around how to use new technologies. And so they start solving this on AWS. And they start building out their data platforms first by solving the needs for their people. And for people, they say, okay, well, can we take these highly specialized individuals? Once they design something and build it once, they create something called infrastructure as code. It's a way to build a template so that once you design something once, you just roll it out many, many times. And it's the same technique that Airbnb uses when just a handful of people in their DevOps group are able to deploy and maintain a global infrastructure. Second, around process, the benefit of having a fully managed service is that it's available on a click. And so an on-demand service for having virtually unlimited storage just at a customer's fingertips, being able to launch a Hadoop cluster in minutes, not months, these are really fundamentally different capabilities for AWS customers. And the third is around the technology. AWS isn't just building big data and analytics technology. We're inventing at the highest speed that we can to solve problems for our customers. And we're developing and rolling out new services around machine learning and putting security improvements and really changing what's available for customers who are building a full platform. So again, not just looking at single individual technologies, but this really enterprise-grade approach to building applications. Now, let's go on a customer journey. And I want to share with you how it is that customers think about and build as they evolve. So I'm going to first introduce to you EarEcstasy. Now, EarEcstasy is not an actual customer, but what I've done is I've taken the real customer journey that we've seen with many of our large customers, and we've boiled this down into the normal steps. So let's go back to 2005. EarEcstasy, they used to manufacture headsets, and they kind of do what you would expect a headset to do. High fidelity, sound was good, but they were a B2B business. They took their product and sent it to distributors who then passed it on to retailers, and the retailers then sold it to customers. And that's fine, but the problem was EarEcstasy had no relationship with their customers. And this is a real challenge when they wanted to improve customer services or launch new products, really having the relationship that would help them. So fast forward a little bit to today. Now, EarEcstasy, they had this great sort of revolutionary idea. What if they could release a new product called the Smart Bud? The Smart Buds are smart connected headsets that they're able to not only stream music, but they can capture things like heart rate, and they can capture GPS, and they connect to a phone so that an application can also guide the music experience. Well, they said, well, what if they went even further? and they were introduced this concept of you could take a picture of where that person is in that moment. It does scene interpretation, and based on the person and where they are, a personalized soundtrack is created and streamed back to that user. So a pretty interesting challenge. So let me walk you through how it is that ear ecstasy went on this journey. So first, they did what many customers do, which is they start by solving the problems of a couple of personas first. And this is a really interesting pattern that we see, is that data platforms tend to solve the needs of a few people first. One of those people is in finance, and we'll call her Miss Lim, and the second, Raymond, is head of product. Now, these two personas are commonly the ones whose needs are being served. Now, Miss Lim, she has the questions that you would expect a finance person to have, which is looking at impact analysis, trying to understand if there's an issue in production, how does that impact the finance? Or looking at what are the inventory holding costs? What are the various costs around producing and distributing these sort of headsets? Now, Raymond, on the other hand, Raymond has different questions. His questions stem to how it is that across various regions, how are people consuming these products? So who are the best customers and who is enjoying and using these products and where are they getting the lift? So these are the two kinds of personas that ear ecstasy wanted to solve for first. So the first thing that they tackled was what, again, we commonly see as a pattern, which is in order to answer these questions quickly, they had to rethink what that data platform looked like. So the old model of buying this really big bit of hardware and maybe a converged appliance that had all the software and infrastructure built in together, well, again, that may have been okay 10 or 20 years ago, but they moved over to something called data pipelines. And data pipelines, as you build a modern data platform, become a really core part of that design. Now, part of the reason why a data pipeline is so important is that it's able to decouple all of the stages. So from when data lands into the system and it comes into a landing zone and it's stored and then it's processed, there's some sort of analysis, and then it's pushed to the user for consumption. By decoupling all of the stages, our customers can then scale, just maybe you want to move from terabytes to petabytes, they can scale just the storage. Or they want to run an additional 100 types of models, they can scale just the compute. So this pipelining is a very effective and elastic way to move data from source to user. So let's look at the first outcome. So you know the two personas, and in order to solve for those personas, they wanted to modernize and consolidate. So let's first start with Miss Lim, so head of finance, and she has the questions around quantities and impact analysis and supplier performance and so on. Well, she knows that there's a really good chance the data that she needs to answer those questions, it lives in one of two places. It either sits in the transactional system, where you might have order history and return, so it's generally in the CRM, or maybe it sits in the ERP, which would be more around the production data and looking at the inventory and some of the other data sources she may have there. Now, a normal pattern that we see is that customers, they start to solve problems in a pretty normal sort of pattern. And the first is around solving modernize and consolidate sort of problems. And often these are the questions around what's the overall state of the business, or being able to look at multiple different types of data sources and looking at those in context of each other. Now, Miss Lim, let's go back and look at her. She had those questions around what's the impact analysis and how are suppliers performing, really looking at what are the financial levers that are being impacted across the business. Now, she knows the data probably lives in one of two places. It's either sitting in the CRM system, looking at order history and maybe looking at returns. Then she also knows that there's a lot of interesting data that lives in the ERP system, and that tends to be around production data or maybe even inventory data. Now, she knows that if she can take these two types of data and bring them together, she can start to answer some of those questions. So, this is a normal pattern that we'll see. And if you're not familiar with these sort of data architectures, or maybe you've seen some that are similar that talk about batch architectures and real-time architectures, we see something very similar in a modern data platform on AWS. And where we have the consumer of the information on the left side, in this case, Ms. Lim, and on the right side, we have the information sources. And you'll see here the transactional and the ERP. But now across the top, we have data pipelines, and later we'll talk about event pipelines, which we'll fill in across the bottom. So there's a principle around starting small and iterate. And this is really a best practice that we see across a lot of our best customers. And they'll, instead of starting with this old big bang approach, which is kind of the old world, and again, it worked at that time, but it's just slow and tends not to be very agile. So solving a specific problem and then replicating it. So let's go back and let's look at Ms. Lim. Now, the questions she wanted to answer, she knows the data probably lives inside the transaction system, which in this case is an Oracle Financials, and the ERP system, which is based in SAP, so off maybe an R3 system. Now, she's going to make a request to her data engineer to say, bring in the smallest amount of data possible into the data lake. So instead of doing a batch load of everything, she says, let's use the Oracle data pump, then maybe a native tool, to extract that data and move it into a landing zone. And maybe use a technology partner like Bright, one of our many, many technology partners that we've built with our community and our ecosystem over time, to take that SAP data and also move it into the landing zone. Now, remember there was a data pipeline, and we'll go a little bit deeper into that in just a moment. Now, the data lands into the landing zone, and then it moves into the data lake. Now, once it's in the data lake, it's gone through a process of being prepared, going through some data cleaning, a bit of transformation, and now it's ready for Lim, who's a Tableau user, to say, okay, well now I'm going to use the tool that I'm already familiar with, go and access data in a nicely structured way, where maybe I'm looking at some data across dimensions, across time, and across product lines, and I'll use a data warehouse, which is Amazon Redshift, which is our fully managed data warehouse offering. But she may also have data that doesn't have a schema. It may be semi-structured data. And so she may want to do a direct query using a service like Amazon Athena, which can directly query data in S3 on the data lake. So this is a pretty normal pattern for pulling in a couple data sources, merging them together, and then making them available to the user through tools they're already familiar with. Now, let's go a little bit deeper into what is a data lake. So we've talked about it. A data lake should have a few characteristics that it's fulfilling. One is that businesses today have data that they already know about. They've got their transactional and ERP data, but in the future, they may want to process audio data or video data or sensor data. So the ability for a data lake to capture anything. The second is that there's different skill sets. You may have some people who are BI tool users, you have SQL programmers, you may have data scientists. They have to dive into the data lake at different levels of depth. So being able to provide an interface where they can get to that data. Now, the flexible access, that's around the tooling. So rather than having every user of this data lake learn new tools, let them use the tools they're familiar with and use industry standard interfaces to access it. And by building on what we'll talk about with S3, making it future-proof in a way that users and customers aren't locked down into a single platform and a single design that becomes rigid, and building one that becomes more and more flexible over time. So within the data lake, we've talked about the usage from Ms. Lim. Now let's talk about Raymond. Raymond cares a lot about who's using the product and where. So in which stores and which kinds of people are using this and are buying these products, because from that, then they can start to make better product marketing decisions. Now, he knows that some of that data already lives in the data lake. He knows that the CRM data is there. So he's going to look to that. But in addition, now he's got more data that's coming in. And he wants to be able to pull that data from social feeds. So from those social feeds, he may be picking up information, signals around what are people saying about the product. Are they happy with it? Are they not happy? Maybe even looking through feedback channels, how people have interacted with their Facebook page, or maybe interacted with other feeds like, say, commenting on Twitter. Now, if he can pull together these two very different looking types of data across the CRM and across these social feeds, he's going to get a really good indication of what people like and why. So Now we get to the second concept, which is around experimentation. Now, experimentation, again, is really important when we think about not every question that you want to ask do you know beforehand. Sometimes it's a process of exploration. So let's go back and let's look at Raymond. Raymond knows that some data lives in the data lake, and we see those feeds coming off the right side, which is for the transactional and the ERP data. But he wants to pull in addition, the social feeds. So we'll just kind of simplify the ingest for those old transactional systems because we're familiar with those. And I'll introduce being able to move social data in through a streaming service. And that streaming service is Amazon Kinesis Streams. It's able to capture these streams of data as they come in, put them up into a landing zone as events. Then the events are processed and moved back up into the data landing zone, which can then be moved to the data lake for analysis. Now, once it lands into the data lake, it's going to be consumed again by Raymond using different tools. He's not a SQL programmer like Lim was. He has to use fully managed BI services, and maybe he just wants to look at dashboards. So he might use a product like Amazon QuickSight, which can just look directly against Redshift, the data warehouse, and give him the dashboards he needs. Or he also might use a tool like Kibana, and Kibana looking back against Amazon Elasticsearch, which handles streaming data really well and pulling that data in from the data lake. So Raymond can then start to look at social sentiment, he can look at product performance, and he's able to do that with tools that he's familiar with. Now, there's the service that we've talked about, which is Amazon Redshift. Now, data warehouses are very effective at answering large-scale, fully dimensional schema-based queries. And what that really means is when you're looking at products, say, product performance over time or against types of customers or against other dimensions, it's able to solve these problems at scale really quickly. And Amazon Redshift is our fully managed data warehouse offering. Now, within this offering, it was built from day one to be cloud native, which means that it can scale from gigabytes all the way up to petabytes. And it's priced to perform at a very cost-effective price point. And we're seeing that for a lot of sort of against traditional technologies, it's about 1/10 of the price to be able to operate. Now, we talked about data pipelines, and now let's double click on that a little bit. Within a data pipeline, there's a pretty common pattern that we'll see. The first is that data doesn't go directly into a data lake. Data first, in its raw form, lands into a landing zone. Now that landing zone uses Amazon's Simple Storage Service, or S3. S3 is virtually unlimited object store that customers have immediately. There's no provisioning of this, and customers just pay for what they use. So when the data lands into S3, they're then able to take those files and move those into the data processing stage of the pipeline. Now you'll see there's a little icon there, which is Amazon Lambda. Amazon Lambda is basically code that runs on a trigger. So when data lands into the landing zone, there's some sensitivity and it says, hey, I realize that there's new data. Take this and move it into the next stage, which is typically ETL and data cleansing. Now, there are many tools that a customer could use at this stage, but often they'll use, especially for large volumes of data, they'll use the Spark ecosystem on top of Hadoop. And Hadoop being run as Amazon EMR, which is our fully managed Hadoop offering. So data will come in, it goes through a set of stages of processing, and then it's moved into the data lake. Now, there's a little bar that you've seen on the bottom that's come up. There's a service I'd like to introduce called Amazon Glue, AWS Glue. And AWS Glue does a few things on behalf of customers. So first, it can do some ETL processing. Second, it can crawl data to find out what is in that data. And the third thing that it does is it creates a single data catalog. And that data catalog is the single version of truth for what lives in the data lake. And this gets really important as we move to more and more types of users and personas on this system. Now, the data lake, again, is based off of Amazon S3. And there are a number of reasons around that, and we'll talk about those later. But using S3 as a storage, then all of your downstream services, in this case it may be Redshift, but it could be others like using Athena or EMR or even using Elasticsearch or others, can consume from the data lake. So this is a normal decoupled pipeline design. Now, let's go back and look at this data architecture. So this is a somewhat simplified view of it. And we'll just do this to kind of make it easier on your eyes as we go through and build it out further. So on the left side, we have the data sources that are coming in. On the right side, we have these consumers. And now we see data at the data pipeline layer, landing in a landing zone, going to the data lake, and then being consumed. And events coming in through the event pipeline and publishing up to the landing zone. Now, let's look at outcome 2. Outcome 2 is typically where our customers want to innovate for new revenues. So let's look back at what Ear Ecstasy is doing in this space. Ear Ecstasy is, for the first time, trying to build a direct relationship with its customers. So let's look at the 2 next personas that commonly are introduced into this data platform. We have the head of marketing, Bala, and we have the head of data science, Christoph. Now, what's interesting with this particular stage of development is that these 2 roles have a very tight relationship. Head of marketing tends to want to ask questions around behaviors of segments. They want to understand, hey, which group of people is enjoying this product and why? So they're looking at these segmentations, but the language that's used for the marketing is actually quite different from how it's actually answered from an analytics perspective. So now we introduce Christoph. Christoph, as head of data science, he's asking questions against the data around how to build a customer segmentation and how to understand what music preference is. And those are very interesting questions to solve for. Also looking at, hey, we're receiving now for the first time this voice and audio data. Can we look for additional signals in that? Or if we're taking in image data for the first time, is there some way to look at that image data, process it, do scene detection, and then act based on that? Now, you can see that there's a relationship between these 2, but they're kind of talking different language. So how do we bring them together? This is where we first start with the problems that we're looking to solve. And so we look to Bala. So we looked ahead of marketing. And he's looking at how are people using it? What are they listening to and when? And what kinds of people? So where he knows that data probably lives is he wants to go and look at how data was collected directly from users. And we'll call this observational data. So observational data coming in from when somebody downloaded the app and they registered their smartbuds for the first time, they know who the person is, they know where they were, and they have some access to that application data. But in addition, there's also the usage data around what kind of music have they listened to up until this point. Now, because they're third parties, and whether that's Amazon Music or TuneIn or Spotify, as they are, the user is consuming these services, they're also creating a trail around what kind of music they've listened to. Now, Bala wants to know what kind of music these people are listening to. So he's able to pull this data because they have access to these API gateways. Now, if we then look at Christoph is trying to solve that problem, but he's doing it from a data analytics perspective. So Christoph says, well, all of this data is, if we look at the mobile data, that lives in the data lake. So we've captured that over time and it's gone into the data lake. But the question around, what about this other kind of data? What about the data that's coming off the headsets? So we're looking at GPS data and heart rate data. Well, does this go into the data lake or not? And so this is a very interesting question that data scientists are facing all the time. You have very nice dense data that you say, okay, this is what we've observed that relates to certain transactions and registrations. We want to store all of that. But what about all this other data that's really sparse? And that whether it's heart rate or movement data, is that really valid or not? Is that useful or not? So Christoph uses what is called a sandbox. And sandboxes are really fundamentally important to building a good data platform that allows for experimentation. Sandboxes need to be fast, they need to be cheap, and they need to be de-risked. So they need to be very low risk. Now, where a sandbox fits, you remember this diagram we've seen before. It sits between the landing zone of raw data and between the data lake. And what the sandbox's job to provide, it's as new data comes in that is unfamiliar, the data scientists can look at this data, run analytics on it, and see if there's anything interesting or statistically valuable within that data. So the data scientist, Christoph, he extracts some of the data, he looks in the sandbox, he runs some analysis on it. And based on that analysis, he starts to build one of a couple things. He builds models, and then he builds result sets. If the result sets look like they're really interesting to the business, and they're things that will answer questions for Bala, the marketing guy, he'll take those and publish those result sets. And that could be something like, for this set of users, if we recommended this music, they probably would like it. So that's what a result set might look like. Now, once he published the result sets, he then pulls through the raw data from the sandbox into the data lake. Now, what will happen over time is that as experiments run, data initially comes in that people haven't seen before, they're not familiar with it. They experiment. If it looks like it's good, it then gets put into a production pipeline so that that data then passes directly from the landing zone to the data lake over time. So let's look at this simplified view, and now that you're familiar with these extra pieces around sandboxing, we'll just kind of clean those up. Now, you'll see that a number of data sources now can flow in, whether it's transactional data or ERP data, social data, connected devices, all sorts of different data can flow in either directly to the data landing zone or through the event pipeline. Goes through some analysis, gets published into the data lake, and then is consumed by the users and those personas. Now, the third and the final outcome is around real-time engagement. And real-time engagement is how it is that a business can respond to their customers' needs or respond to events in near real time. Now, the language that we tend to talk about are capturing windows of opportunity. So when somebody has asked for something or shown interest, within that window of time, are you able to respond to their request or to their need? So let's talk about this personalized life soundtrack, this sort of ambitious goal that Ear Ecstasy started on and said, hey, when we've got these connected devices, what can we offer to our users? So whether the lady who's using this is doing yoga or she's reading a book at home or she's out exercising, whatever it is she's doing in her day, she's able to get the perfect music based on who she is and what she likes. Now, how do we start to solve for this? We've got these smart buds, and the smart buds have been collecting information, requests to say like, hey, I'm tired, can you play me some music? Now, at this point, maybe a fully managed service like Amazon Comprehend using Transcribe will be able to take the request, understand what's been asked for, understand in a natural language, say, hey, what she's asking to do is play music, but we still need to recommend what to play. So there's another path, which is capturing that request, being able to take in maybe the GPS. Where is she? Maybe looking at heart rate. Is she exercising or is she at rest? And then based on that, start to pull together these two data sources, pair that together with her history. So based on when she's asked similar things, where was she and what was she doing and what was her state? And then interestingly, being able to put her together on what's called a cohort. A cohort's a group of people or things that look very similar. So matching her history, her request, and people who are similar to her, they're able to say, hey, I actually think that if you're tired, 21 Pilots for you is the perfect thing to recommend in this moment. Now, there's the second side, and this one is kind of interesting because we've talked about voice, and most people are familiar with maybe being able to make a voice request and listen to music. But what about being able to take a picture and get music? So this is kind of an ambitious task that they set out to do. So what they did was they designed the mobile app. When you take a photo, it first goes and uses something like Amazon Recognition Image to do scene detection. Say, okay, in this picture, I see a chair and a table and a desk, and sort of all with these confidence ratings of what those objects are. But then we also want to do a bit more of a deeper dive. I think it's an office, but what kind of office? So using models that have been built using Amazon SageMaker, which is a machine learning, fully managed machine learning service, is being able to say, let's do an image reclassification of all these different types of office environments. And ultimately what we want to do is say, can I detect what kind of office she's sitting in? So pairing together these two bits of information, say, not only is she in an office, she's in a quiet office. And so based on that, and based off her history and based off people who are like her, what we think is in this moment that actually classical music would be a really good play. So again, just an interesting path and a way of thinking about how to start pulling together different non-traditional data sources and doing it in near real time to be able to solve these problems for the customer. So let's go back and let's look at how this fits into the overall structure. So this modern data platform has those same data pipelines and event pipelines, but now you see that in that AI and analytics space, not just publishing result sets, but publishing the predictive models into the event pipeline so that when that request comes in, maybe it's that video stream or maybe it's the image stream or maybe it's the audio stream, being able to use advanced AI services to interpret it, score that against the model, and be able to publish out and respond with an event, with an action. So again, what you're looking at here, not just for ear ecstasy, but for many of our best customers, this is the approach of how they build a modern data platform. So let's look back at the ear ecstasy journey. Ear ecstasy embarked on a similar journey that many of our customers do. The first is that they launched a project around modernize and consolidate. This is pulling together different kinds of data sources to get a better view of the business and a better view of their customers. The second was projects around innovating for new revenue. And these tend to be projects that are around segmentations or building better personalization initiatives. And the third was around being able to capture these real-time engagements. So being able to look at a window of opportunity from when a customer has expressed interest and being able to solve that in near real time. Now, how do you start? As you're ready to take these great ideas that you have and start to build a better business, I've got a couple recommendations for you. The first is step away from this idea of this big bang approach of starting with these huge sort of overarching ideas and these really big projects. Start small. Pick a few things that are going to these shortlisted projects that are going to directly relate to customer success and what matters to your customer. Once you have a baseline for a small project like that, you can get started, test it, see if you're on the right path, and then iterate and develop very quickly. Now, the second part of this is building an infrastructure and a platform that will help you. So building these very nicely decoupled pipelines allow you to flow a little bit of data into the data lake or flow data into a sandbox for experimentation where your data scientist can start to do machine learning and build these really interesting models and outcomes for the business. And the third is take advantage of AWS resources. Engage our SAs early, our solution architects, to help you in your early stage of design. The ones who can come in and say, hey, this is a really great approach, or maybe you could think about this slightly differently. Or if you need that hands-on keyboard sort of support, you can engage our professional services teams. Now, to gain more confidence and hands-on experience with AWS, access the digital and classroom training built and delivered by AWS experts. AWS also has a wide partner ecosystem to help you focus on your success and take full advantage of all the business benefits that AWS has to offer. Learn more about how APN partners can help you and find the right APN partner for your needs. Visit the AWS APN booth at our showcase. Now, for the rest of this track, we have already talked about today how to build a good data platform, but there's 4 more sessions that you might find really interesting. The first is around how to solve the needs of your users. So for the people who will actually access this platform, what are the best ways they can do it? The second is, what's a good data lake design? Today we talked a little bit in this session around what a data lake is, but we'll go even deeper into what design practices might look like. You can then look at serverless data pipelines, and this is how to start to feed that data into the data lake. And the final is, maybe you've got existing infrastructure like maybe old data warehouses, and you want to think about how to modernize, migrate, and move those onto the cloud. Our final session will be for you. So with that, I want to thank you very much. I hope the rest of your sessions are great, and thank you for joining us today.